For most of human history, Earth was not just our home, it was everything. The ground beneath our feet, the sky above our heads, the stars that moved in strange, repeating patterns. Ancient civilizations believed Earth stood at the center of existence, chosen by gods, crafted with intention. Then science arrived, and with it humility. We learned that Earth is not the center of the universe, not even the center of our galaxy. Just one planet orbiting an average star in the outer arms of the Milky Way. And yet, the question refuses to disappear. Is Earth special? At first glance, Earth does not seem extraordinary. Our sun is one of hundreds of billions of stars in the Milky Way. Our galaxy is one of hundreds of billions of galaxies in the observable universe. When viewed from a cosmic perspective, Earth is a pale blue dot suspended in darkness, smaller than a grain of sand on a vast beach. Nothing about its location screams importance. But special does not always mean central. Sometimes, special means rare in the right way. Earth is special not because it exists, but because it lives. Life is not a simple phenomenon. It is not just motion or growth or complexity. Life is chemistry organized against entropy, sustained for billions of years in a universe that naturally drifts toward disorder. For life to arise, and more importantly, to survive, a planet must meet an extraordinary number of conditions, not once, but continuously, over immense spans of time. Earth passed every test. The first requirement for life is energy. Earth receives a steady, stable flow of energy from the sun, not too intense to strip the planet bare, not too weak to freeze it into silence. This balance is astonishingly precise. A slight shift inward, and Earth would resemble Venus, a runaway greenhouse world with surface temperatures hot enough to melt lead. A slight shift outward, and Earth could resemble Mars, cold, dry, and mostly lifeless. This narrow region is known as the habitable zone, but that name is misleading. Being in the habitable zone does not guarantee life. It merely opens the door. Earth did far more than step through it. Earth formed at just the right time in cosmic history. Early in the universe, heavy elements like carbon, oxygen, iron, and phosphorus did not exist. They were forged inside massive stars and scattered by supernovae. Earth was born after generations of stars had lived and died, enriching the cosmic environment with the raw materials of life. We are quite literally made of stellar remnants. Even with the right ingredients, Earth could have failed. Many planets do. During its early history, Earth endured relentless asteroid impacts, violent volcanic activity, and extreme heat. Yet instead of becoming sterile, Earth cooled, stabilized, and transformed. Oceans formed. Continents emerged. The planet began to regulate itself in a way that still astonishes scientists today. Liquid water, the foundation of life as we know it, covered the surface. Not briefly, but persistently. For billions of years, Earth maintained oceans despite changes in solar brightness, atmospheric composition, and geological upheaval. This long-term stability is not guaranteed by physics alone. It is the result of complex feedback systems involving the atmosphere, oceans, rocks, and living organisms themselves. Earth did not merely host life. Life reshaped Earth. Simple microorganisms altered the atmosphere, releasing oxygen as a waste product. What began as a poison slowly transformed the planet, enabling complex life to evolve. The air we breathe is not a default setting. It is a biological creation. This raises a profound idea. Earth supports life not because it was designed for life, but because life and Earth co-evolved, shaping each other in a delicate, ongoing dance. If Earth is special, it is not because it was perfect from the start, but because it survived imperfection long enough for life to take hold. And this leads to the deeper question that challenges everything we know. If Earth could do this, how many other planets did too? To understand why Earth supports life, we must look beyond what is visible. Mountains, oceans, forests, and skies are only the surface expression of much deeper systems. Ancient, invisible processes that work continuously to keep this planet alive. Life on Earth is not protected by a single factor, but by a network of safeguards, each one compensating for the failure of another. Remove just one, and the entire system begins to unravel. One of the most critical of these systems is Earth's atmosphere. Earth's atmosphere is not simply air. It is a carefully balanced envelope of gases that performs multiple life-preserving functions at once. Oxygen enables complex organisms to extract energy efficiently. Carbon dioxide regulates temperature and fuels photosynthesis. Nitrogen stabilizes the atmosphere and prevents runaway chemical reactions. This precise balance did not exist at Earth's birth. It evolved over billions of years through volcanic activity, chemical reactions, and biological processes. The atmosphere acts as a thermal blanket, trapping enough heat to prevent Earth from freezing while allowing excess heat to escape. Without this greenhouse effect, Earth's average temperature would be far below the freezing point of water. Yet too much greenhouse trapping, as seen on Venus, transforms a planet into an inferno. Earth remains suspended between these extremes. Just as important is what the atmosphere blocks. High-energy radiation from space constantly bombards the solar system. Earth's ozone layer absorbs most of the sun's ultraviolet radiation, preventing widespread genetic damage to living organisms. Without it, life would be forced underground or underwater if it could exist at all. Beneath the atmosphere lies another hidden shield, Earth's magnetic field. Deep within Earth, a molten iron core churns slowly, generating a powerful magnetic field that extends far into space. This invisible barrier deflects charged particles from the solar wind, preventing them from stripping away the atmosphere. Mars once had liquid water and a thicker atmosphere, but after its magnetic field weakened, the solar wind eroded its protective layers. Earth avoided this fate because its interior remained active. Earth's size is crucial here. It is large enough to retain internal heat for billions of years, but not so large that it becomes geologically stagnant. This internal heat drives plate tectonics, one of Earth's most underappreciated life support systems. Plate tectonics continuously recycle Earth's surface. Carbon is pulled from the atmosphere, locked into rocks, carried into the mantle, and eventually released again through volcanic activity. This carbon silicate cycle acts as a planetary thermostat, stabilizing global temperatures over immense timescales. When Earth warms, carbon is removed from the atmosphere. When Earth cools, carbon is released. Few planets are known to possess such a self-regulating mechanism. Tectonic activity also reshapes continents, creates diverse environments, and delivers nutrients to oceans. Life thrives on change, and Earth provides it in controlled doses, enough to drive evolution, but not so much that it wipes the slate clean too often. Then there is water, the most essential ingredient of all. Earth did not merely acquire water, it held on to it. Water molecules are light and easily lost to space. Yet Earth's gravity, magnetic field, and temperature allowed oceans to persist for billions of years. These oceans regulate climate, store heat, dissolve minerals, and provide a stable environment where complex chemistry can unfold. Water also enables feedback loops that stabilize the planet. Ice reflects sunlight, cooling Earth when temperatures rise. Clouds regulate heat exchange. Ocean currents distribute energy across the globe, preventing extreme temperature differences between equator and poles. Even Earth's axial tilt plays a role. The planet tilts just enough to create seasons, driving biological cycles without producing extreme climate chaos. This tilt is stabilized by the Moon, an unusually large satellite relative to its planet. Without the Moon, Earth's axis could wobble wildly, causing dramatic and frequent climate shifts that might prevent long-term biological stability. Each of these features alone is impressive. Together, they form a system that borders on miraculous. Earth does not support life by accident. It supports life because countless processes, geological, chemical, atmospheric, and biological, align continuously, correcting deviations before they become catastrophic. The deeper scientists look, the clearer it becomes. Earth is not merely habitable, it is actively habitable, which raises an unsettling possibility. If Earth requires this many conditions working together, then planets like Earth may be far rarer than we once imagined. Earth may appear stable today, but its history tells a far more precarious story. The planet that supports life now has repeatedly stood at the edge of total annihilation. Earth's success was not guaranteed. It was earned through survival, through countless near catastrophes that could have erased life permanently. Early Earth was a hostile world. Its surface was molten, its atmosphere thick with toxic gases, and its skies filled with falling debris. Massive asteroid impacts were common, each one capable of boiling oceans and sterilizing the surface. Yet life emerged surprisingly early, almost as soon as conditions allowed it. This alone suggests something remarkable. Life is resilient, but only if the environment gives it enough time. Time is Earth's greatest gift. Earth avoided frequent global resets. While impacts occurred, none were large enough to permanently destroy the planet's oceans after life began. Jupiter may have played a role here. As the largest planet in the solar system, Jupiter's gravity acts as a cosmic shield, redirecting or absorbing many asteroids and comets that might otherwise strike Earth. Without this distant guardian, Earth's surface may have been repeatedly sterilized. Even so, extinction events were inevitable. Over the last 540 million years, Earth has experienced at least 5 major mass extinctions. Each wiped out the majority of existing species. The most devastating, the Permian extinction, eliminated nearly 90% of life on Earth. Volcanic eruptions, climate collapse, ocean acidification, and atmospheric poisoning pushed the biosphere to the brink. And yet, life persisted. Earth's biosphere did not collapse entirely because the planet retained its core life support systems. Oceans remained liquid. The atmosphere stayed intact. The magnetic field continued to function. Each time life was nearly erased, the planet itself remained viable, allowing evolution to restart. This distinction is crucial. Many planets may briefly host life, but only a few may remain stable long enough for complexity to arise. Intelligent life requires billions of years of uninterrupted habitability. Earth managed to provide that window. The Sun, too, has been unusually stable. Many stars are violent, flaring unpredictably and bombarding their planets with radiation. Our Sun, a middle-aged yellow star, burns steadily. Its brightness has increased gradually, allowing Earth's climate systems time to adjust. Sudden changes would have been fatal. Even Earth's orbit is remarkably circular. Highly elliptical orbits cause extreme temperature swings, making long-term climate stability unlikely. Earth's near-circular path keeps seasonal variations within survivable limits. But perhaps Earth's most astonishing trait is its ability to recover. After each catastrophe, life rebounded, not to its previous state, but to something more complex. Simple organisms gave rise to multicellular life. Marine ecosystems expanded onto land. Mammals emerged from the shadows of extinct dinosaurs. Each disaster cleared ecological space, allowing new forms of life to evolve. This pattern reveals a deep truth. Earth does not preserve life in stasis. It encourages adaptation. The planet's moderate instability, shifting continents, changing climates, rising and falling sea levels, drives natural selection without pushing the system beyond recovery. Too little change, and life stagnates. Too much, and life collapses. Earth remains balanced between these extremes. But this balance is fragile. Small changes can cascade into planetary-scale consequences. A slight alteration in atmospheric composition, orbital parameters, or solar output could tip Earth into a permanent ice age or a runaway greenhouse state. The margin for error is narrow. This fragility reshapes how we view Earth's rarity. It is not enough for a planet to be Earth-sized, rocky, and in the habitable zone. It must also survive billions of years of cosmic hazards, internal instability, and stellar evolution, without crossing irreversible thresholds. This dramatically reduces the number of worlds that could host advanced life. Which brings us to the next question, perhaps the most unsettling of all. If Earth survived against such odds, why don't we see others like it? When humans first began to understand the size of the universe, optimism flourished. With hundreds of billions of galaxies, each containing hundreds of billions of stars, it seemed inevitable that life must be everywhere. Surely Earth could not be unique. Surely the universe would be alive with voices. And yet, the cosmos is silent. This contradiction lies at the heart of one of the greatest scientific mysteries ever posed, the Fermi paradox. If intelligent life is common, then where is everyone? Why do we see no evidence of civilizations, no signals, no artifacts, no unmistakable signs of cosmic engineering? One possible answer is that Earth is extraordinarily rare. Modern astronomy has revealed that planets are common. Most stars host planetary systems. Many of those planets are roughly Earth-sized. Some orbit within habitable zones. On paper, the universe seems filled with potential Earths. But potential is not reality. The vast majority of these planets differ from Earth in critical ways. Many orbit red dwarf stars, which are prone to violent stellar flares capable of stripping atmospheres and sterilizing surfaces. Others are tidally locked, with one side permanently facing their star, creating extreme temperature contrasts. Some lack magnetic fields. Others have unstable orbits, chaotic climates, or no plate tectonics. Each missing factor narrows the window for long-term habitability. Then there's the concept of the rare Earth hypothesis. This idea suggests that while microbial life may be common, complex life requires such a precise combination of conditions that Earth-like planets may be exceedingly uncommon. Not impossible, but statistically rare. According to this view, Earth is not just in the habitable zone of its star. It is in a galactic habitable zone, far from the intense radiation near the galaxy's core, yet rich enough in heavy elements to form rocky planets. It formed in a relatively calm stellar neighborhood, avoiding close supernova explosions that could sterilize nearby systems. Even Earth's evolutionary path may be unusual. It took nearly 4 billion years for intelligent life to arise. If complexity were easy, the universe might already be filled with advanced civilizations. The long delay suggests that intelligence may be an improbable outcome rather than an inevitable one. Another possibility is timing. Perhaps the universe is not silent because life is rare, but because it is young. Complex life requires billions of years to evolve. Technological civilizations may exist only briefly before self-destruction or transformation into forms we cannot detect. We may be early or alone in our era. There is also the uncomfortable idea that advanced civilizations may choose silence. They may avoid broadcasting their presence, either for safety or philosophical reasons. Or they may have moved beyond technologies we recognize, leaving no detectable traces. Yet despite these possibilities, the absence of evidence remains striking. Earth has produced a species capable of altering the planet, sending probes beyond the solar system, and searching the stars for companions. In cosmic terms, this happened astonishingly fast. The fact that we do not see similar activity elsewhere forces us to confront a sobering thought. Earth-like worlds may be rare not just in space, but in time. If this is true, then Earth's significance deepens. It may represent a fleeting phase, a brief moment when matter becomes aware of itself, a temporary window in an otherwise silent universe. And if Earth is rare, then its value is immeasurable. But there is another angle to this mystery, one that shifts the focus away from the stars and back toward ourselves. If Earth is special, what does that mean for our responsibility to it? This moment is unprecedented. Previous mass extinctions were driven by natural forces, volcanic eruptions, asteroid impacts, climate shifts beyond biological control. Today, the dominant driver of planetary change is intelligent life itself. The carbon cycle that once stabilized Earth over millions of years is now being altered in centuries. Atmospheric composition is shifting faster than most ecosystems can adapt. Oceans are warming and acidifying simultaneously. Biodiversity is declining at a rate comparable to past extinction events. Earth will survive these changes. It always has. The question is whether we will. This distinction matters. Earth does not need humans. Humans need Earth's finely balanced systems. Civilizations rise and fall within environmental limits. When those limits are exceeded, collapse follows, not as punishment, but as consequence. What makes humanity different is awareness. We're the first species to know that Earth is special. We understand plate tectonics, climate feedback loops, atmospheric chemistry, and cosmic hazards. We can model future outcomes and trace past failures. Knowledge places us in a strange position. We are both participants and observers in Earth's story. Some argue that Earth has endured worse and will recover again. This is true, but recovery often takes millions of years. Human civilization does not have that kind of time. The conditions that allowed agriculture, cities, science, and global cooperation are narrow and fragile. Even small shifts in climate or ecosystem stability can unravel them. If Earth is rare, then the stakes rise dramatically. Damaging this planet would not just be a local tragedy. It could be the loss of one of the universe's few experiments in complex life. If intelligent civilizations are uncommon, then preserving this one becomes a cosmic responsibility. Yet there is another possibility. Humanity may represent Earth's next evolutionary step. Life began as simple chemistry, evolved into complex organisms, and eventually produced intelligence capable of leaving the planet. In this view, Earth is not just a cradle, it is a launch point, a world that nurtured awareness until it could spread beyond its origin. But this future is not guaranteed. A civilization that destroys its home before achieving stability never reaches the stars. Many theorists believe this is the answer to the cosmic silence. Intelligent life often fails its first planetary test. It gains power faster than wisdom. It destabilizes the systems that support it, and it disappears. Earth may be watching this test unfold now. Whether we pass depends on choices made within a few generations, a blink in geological time. Technology alone cannot solve this. Understanding must guide action. Survival requires aligning human systems with planetary limits, rather than pushing endlessly against them. This realization transforms the original question. Is Earth special? Yes, because it produced a species capable of asking that question. Why does Earth support life? Because life learned slowly and painfully how to work within Earth's constraints. How rare is Earth in the universe? Rare enough that losing it would mean losing something the cosmos may never replace. And now, the final question emerges, one that no planet has ever answered before. What will an intelligent species do when it realizes its world is irreplaceable? The future of Earth is no longer dictated solely by geology, biology, or astronomy. For the first time, it is shaped by intention. Human decisions now influence atmospheric chemistry, ocean circulation, land systems, and even the long-term trajectory of life itself. This shift marks a turning point not just in Earth's history, but in the history of the universe. If Earth is rare, then it may represent something even more profound than a habitable planet. It may be a prototype. Life on Earth has already transformed the planet once, during the Great Oxygenation Event, when microscopic organisms altered the atmosphere so dramatically that most existing life forms went extinct. Today, a similar transformation is underway, but driven by a single species with foresight and choice. The outcome will determine whether Earth remains a stable life support system or transitions into a new, uncertain state. One possible future is collapse followed by recovery. In this scenario, human civilization destabilizes Earth's climate and ecosystems beyond its own tolerance. Civilization fragments or disappears, while life continues in altered forms. Over millions of years, Earth heals, forests return, Oceans stabilize, new species evolve. Earth survives, but humanity becomes a brief evolutionary experiment, remembered only in fossil layers. Another future is stabilization. In this path, humanity recognizes the limits of Earth's systems and redesigns its civilization accordingly. Energy production aligns with planetary cycles. Carbon emissions are balanced by natural and engineered sinks. Biodiversity is preserved not as a luxury, but as infrastructure. The planet remains habitable not because it is untouched, but because it is understood. This outcome would be unprecedented. A civilization that chooses restraint over expansion, cooperation over short-term gain. Then there is the third possibility, expansion without abandonment. In this future, Earth remains protected while humanity gradually extends life beyond its birthplace. Space habitats, lunar bases, and planetary settlements do not replace Earth, but reduce pressure on it. Earth becomes a preserved biosphere, a living archive of 4 billion years of evolution, while life spreads carefully into the solar system. If intelligent life is rare, this expansion could be the universe's way of preserving itself. Earth would not just be special, it would be foundational. Yet expansion carries its own dangers. Exporting life without wisdom risks repeating the same mistakes elsewhere. A species that cannot live sustainably on one planet is unlikely to manage many. Which brings us back to rarity. The more we learn about planetary systems, the more Earth appears to sit at an improbable intersection of circumstances. Its long-term climate stability, geological activity, protective magnetic field, large moon, stable star, and evolutionary history may not be common. Earth-like worlds may exist, but separated by vast distances in space and time. This reframes humanity's search for extraterrestrial life. Finding another living world would not diminish Earth's importance. It would enhance it. It would mean life is not a fluke, but a tendency, given the right conditions. Until that discovery is made, Earth remains our only example. The only place where the universe knows itself. The only world where atoms learn to think, wonder, and ask whether they are alone. Whether Earth stays special depends on what happens next. If humanity fails, Earth will remain a silent witness to a lost possibility. If humanity succeeds, Earth may become the birthplace of a cosmic legacy. And so the question that began this journey evolved one final time. Is Earth special? Or is Earth the beginning? When we step back far enough, Earth stops being just a world and becomes an idea, a demonstration, a question asked by the universe itself. Out of lifeless matter and blind physical laws, something arose that could observe those laws, challenge them, and search for meaning beyond survival. Earth is not only a place where life exists, it is a place where existence reflects on itself. This may be Earth's deepest significance. From a cosmic perspective, Earth is absurdly fragile. A thin atmosphere clings to a rocky surface. A narrow temperature range keeps water liquid. A magnetic field deflects invisible storms from the sun. All of this persists within a universe that is mostly empty, cold, and hostile. The contrast is stark. Life is not the rule, it is the exception. And yet, here it is. Earth shows that complexity can emerge from simplicity, that order can arise in chaos, and that awareness can bloom in darkness. It proves that the universe is not just a place where things happen, but a place where things can matter. If Earth is rare, then every living organism here is part of a vanishingly unlikely chain of events stretching back billions of years. Every breath is connected to ancient oceans. Every thought traces its origins to stardust forged in long-dead suns. Nothing about this was guaranteed. This realization changes how we frame the search for life elsewhere. The question is no longer just, are we alone? But what does it mean if we are not? Or if we are? If life is common, then Earth is one voice in a vast cosmic chorus. If life is rare, then Earth is a solo performance, brief, precious, and irreplaceable. In both cases, Earth remains extraordinary. It is the only known world where life survived long enough to become intelligent. The only place where beings can wonder about the universe's origin, its fate, and their own role within it. The only planet that asks whether it is special. And that may be the final answer. Earth is special not because it was chosen, but because it endured. Not because it is perfect, but because it remained stable long enough for imperfection to evolve into intelligence. Not because it stands alone, but because it stands aware. The universe may be filled with planets. It may even be filled with life. But until proven otherwise, Earth is the only place where the universe has learned to look back at itself and ask questions. Whether Earth stays special now depends on one fragile factor: us. If humanity learns to live within the systems that made it possible, Earth may continue its role as a living world for millions of years to come. If not, Earth will move on without us, silent once again, its greatest experiment concluded. In that sense, Earth is not just rare. It is unfinished. Its story is still being written, not by geology or biology alone, but by choice. And that makes this planet more than a home. It makes it a responsibility. To truly understand how rare Earth may be, we must confront an uncomfortable truth. The universe does not favor life. Its fundamental laws allow life, but they do not optimize for it. Most regions of space are lethal, filled with radiation, vacuum, extreme temperatures, or crushing gravity. Life exists not because the universe is friendly, but because it occasionally allows narrow pockets of stability to persist long enough for complexity to emerge. Earth occupies one of those pockets. From a probabilistic standpoint, Earth appears to sit at the edge of what is statistically reasonable. Each factor supporting life may not be extraordinary on its own, but their simultaneous presence over billions of years is what makes Earth exceptional. Planetary formation is chaotic. Orbits shift. Stars flare. Impacts occur. Atmospheres escape. Magnetic fields weaken. Oceans evaporate. Most planets fail not instantly, but gradually, slipping outside life-supporting conditions without drama or warning. Earth did not. Some scientists argue that we overestimate Earth's rarity because we observe it from within. This is known as the anthropic principle, the idea that we can only observe conditions compatible with our existence. In this view, Earth feels special because if it weren't, we wouldn't be here to notice. Life may be common, but observers only arise where conditions allow it. Yet this explanation feels incomplete. The anthropic principle explains why we exist here, but not how often such places arise. It does not erase the improbability, it merely reframes it. Even if observers only appear on rare planets, those planets remain rare. Earth's geological longevity is especially striking. Many planets cool too quickly, losing internal activity. Others remain too active, locked in perpetual volcanism. Earth maintained internal heat long enough to drive plate tectonics, magnetic field generation, and atmospheric recycling for over 4 billion years. This duration may be one of the rarest traits of all. Then there is biological timing. Life began early, but complex life took an extraordinarily long time to evolve. For most of Earth's history, life remained microscopic. Intelligence arrived late, dangerously late. If a few key steps had taken longer, the sun's gradual brightening might have rendered Earth uninhabitable before humans ever appeared. This suggests that Earth did not just support life, it raced against time. This race may explain the cosmic silence. Intelligent life may be fragile not only in space, but in time. Civilizations might emerge during brief windows, separated by millions or billions of years. The universe could be full of ruins and futures, but empty in the present moment. If so, Earth may not be alone, but it may be early, late, or fleeting. And that makes the present moment extraordinary. Right now, Earth hosts oceans, forests, intelligence, technology, and awareness simultaneously. This convergence may never happen again here, or anywhere else. The universe does not pause. Conditions change. Windows close. Earth is not just rare spatially. It may be rare temporally, which leads to a profound realization. Earth's value is not only what it is, but when it is. At the deepest level, the question is Earth special? Maybe the wrong question. A better one might be, what does Earth represent? Earth represents a threshold, the point where matter crosses from chemistry into biology, from biology into consciousness, and from consciousness into responsibility. It is not the end of a process, but the beginning of one that may extend far beyond this planet. For the first time, life is no longer confined to instinct and adaptation. It can reflect, plan, preserve, and choose. This transition is as significant as the origin of life itself. If it fails, Earth remains remarkable but isolated. If it succeeds, Earth becomes the seed of something much larger. In this sense, Earth's rarity may be a filter rather than a fluke. The universe may produce countless planets, fewer living worlds, even fewer intelligent species, and only a handful that survive the moment when intelligence gains planetary power. Earth is currently passing through that narrow gate. Nothing in physics guarantees success. Technology accelerates faster than wisdom. Social systems evolve slower than environmental consequences. The same intelligence that allows us to understand Earth's fragility also gives us the ability to ignore it. This tension defines our era. But there is hope embedded in awareness itself. Earth produced a species capable of measuring atmospheric carbon, modeling future climates, tracing evolutionary history, and recognizing its own impact. No asteroid, volcano, or solar flare ever paused to reconsider its effects. Intelligence can. If Earth remains habitable for another million years, it will not be because conditions stayed favorable by chance alone. It will be because life, through intelligence, chose continuity over collapse. In that future, Earth may become something unprecedented, a planet that learned to protect itself. Such a world would not lose its special status by sharing life with others. It would gain meaning by ensuring life continues. Earth would become the reference point, the world that crossed the threshold successfully. And if humanity eventually carries life beyond Earth, this planet will always remain singular. Not because it is the only life-bearing world, but because it was the first one we knew, the only one that gave us everything before asking anything in return. Earth does not need to be unique to be precious. It needs only to be finite. In an infinite universe, finiteness is what gives value. Earth is where the universe first learned to care about its own survival. Whether that lesson endures will decide if Earth is remembered as a miracle or as a missed opportunity. As we reach the conclusion of this journey, it becomes clear that Earth is far more than a pale blue dot drifting through space. It is a living experiment, a planet that has survived against improbable odds, nurtured life, and produced intelligence capable of reflection and choice. Its story is both ancient and immediate, spanning billions of years, yet arriving at a moment where conscious beings can alter its fate. Earth's uniqueness lies in the combination of factors that sustain life. Its orbit in the sun's habitable zone, the stability of its star, the presence of liquid water, a protective atmosphere, a magnetic field, a large moon stabilizing its axial tilt, active plate tectonics, and the right chemical composition. Each feature is remarkable, but together they form a network of conditions almost impossible to replicate elsewhere. The odds against a planet achieving all of these at once are astronomical, making Earth rare, perhaps extraordinarily rare, in the vast cosmos. Yet rarity alone does not capture its full significance. Earth is special because life on it is self-aware. Life has evolved to a point where it can ask, why do we exist? Why here? Why now? This self-awareness transforms Earth from a mere rock orbiting a star into a window through which the universe glimpses itself. Conscious beings are not merely passengers on Earth. They are witnesses to its story, inheritors of its fragile systems, and potentially stewards of its future. The fragility of Earth is as remarkable as its resilience. Throughout history, the planet has faced cosmic hazards, mass extinctions, and extreme climate shifts. It has endured asteroid impacts, massive volcanic eruptions, and dramatic fluctuations in atmospheric chemistry. Yet through each trial, Earth's systems remained intact enough for life to persist and evolve. It is this combination of fragility and durability that makes the planet exceptional, a world capable of supporting billions of years of continuous biological complexity. The rarity of Earth also highlights humanity's responsibility. For the first time, intelligent life can influence planetary-scale systems deliberately. Our species has the power to stabilize or destabilize climates, to protect or destroy ecosystems, to ensure that life continues or to hasten its decline. This is a unique test in cosmic history. No other life form is known to have wielded such power over its home planet while also possessing the consciousness to understand the stakes. The universe may produce many habitable worlds, but few, perhaps none besides Earth, have hosts capable of comprehending and managing their own ecological fate. If Earth succeeds in this test, its story will extend far beyond the planet itself. Humanity may become a cosmic agent, spreading life to moons, planets, and star systems. Earth would become the cradle of a wider biosphere, not just a single world, but the origin of life across space. If Earth fails, the planet will continue, but the conscious beings who could have shaped its legacy will vanish. The lesson remains: Earth's value lies not only in its uniqueness, but in the choices it inspires. Ultimately, Earth is a threshold in the universe, the first known example of a planet that produced life capable of reflection, technology, and self-preservation. It is an experiment that continues in real time, asking questions about survival, responsibility, and meaning. Its rarity and resilience make it precious, its fragility makes it urgent, and its self-aware life makes it profound. In the cosmic scale, Earth may appear as a mere dot. In reality, it is a singularity of existence, a point where matter learned to understand itself, where life paused to contemplate its own origins, and where intelligence gained the chance to ensure that the story continues. It is rare, possibly unique, and utterly irreplaceable, a fragile oasis in a universe mostly inhospitable to life. The ultimate truth is both humbling and empowering. Earth is special because it exists, because it survived, and because life on it now has the power to choose its destiny. Its rarity, its resilience, and the consciousness it has nurtured make it one of the universe's most extraordinary phenomena. And in recognizing this, humanity is faced with the greatest opportunity it has ever known: to protect, preserve, and perhaps extend this miracle, ensuring that Earth's legacy continues, not only for millennia, but perhaps for eternity. Earth is not just our home. It is the universe becoming aware of itself, standing on the edge of time, and asking us to decide what comes next.